Okay, so this is lesson 2, part 4. This is where we left off. We talked about qualitative and quantitative research, and now we're going to pick it up here at the levels of measurement. So we basically have 4 levels of measurement, okay? And they go from weakest to strongest. There are basically 4 ways to measure something, okay? To measure anything. There's the nominal level of measurement, then we have the ordinal level of measurement, we have the interval level of measurement, and then we have the ratio level of measurement. And again, this is all discussed in your book. I'm just kind of explaining the concepts here to you. So the nominal level is the weakest level of measurement. The word nominal actually just comes from nom or name, right? And it's basically when we just use numbers to stand in for people or objects or characteristics. So we just assign numbers, but the numbers don't actually mean anything. It's like your student ID numbers. Every one of you has a UNA student ID number, right? The numbers don't actually mean anything in terms of like value. It's like if one of you has student ID number 5,000 and another one of you has the student ID number 1,000, it doesn't mean that the 5,000 is greater than the 1,000. I mean, there's no real value, but it's the nominal level of measurement, right? It's just a number that stands in for something else, and we use these all the time. Like in content analysis, when I do my little, I design my little coding sheet. Usually the very first question, like I said, I do a lot of studies of newspapers. I'm very interested in news texts. So I'm actually just finishing a study where I'm examining the St. Louis Post-Dispatch and the New York Times. I'm looking at how they covered the Black Lives Matter protests last year, right? And early this year. So I have the very first question on my coding sheet is, which newspaper is it? The St. Louis Post-Dispatch, number 1, or the New York Times, number 2? The 2 is not greater than the 1. The 1 is not lesser than the 2, but I have to identify them with numbers because at the end, when I go into my statistical program, I'm just going to enter a bunch of 1s and 2s. So I'm measuring the newspaper, but I'm not measuring it in any sophisticated way. This is just the nominal level of measurement. The ordinal level of measurement is kind of a step up. Here's where we're actually ranking the values in some order along some dimension. For example, smallest to largest, low, medium, high. Those are examples. Here's a good example of the ordinal. Remember, and it's always in order, okay? We're ranking them in order. But we don't know the distance. There's not like an equal distance between the objects. So for example, educational attainment. You've all seen this question on surveys. What is your level of education? Some high school, some college degree. Most of you would select on this, you would select 3, some college, right? 4 would be if you have a college degree. 5 is if you like have a graduate degree, right? So the numbers now have some meaning, don't they? Because the 5 is greater than the 1 or the 0, right? But it's still not like a real number in the sense you can't do like, well, 5 minus 3 is 2, and 5 minus, you can't do that, and there's not an equal distance between the different categories, between the different objects or events. Okay, so that's the ordinal level of measurement. There's also the interval level of measurement. This is now the interval and the ratio, guys. This is like these are the highest levels of measurement. This is where basically now the numbers are just real numbers. Okay, you can kind of think about these as being the same, interval and ratio, I guess, but the only difference is that in ratio there's a true 0 point. So ratio level is just, I mean, the numbers are just real numbers. They just, like 1 is 1, 5 is 5. So let me give you an example to kind of make this stick. Let's say you wanted to measure time. Remember I told you in some of the studies that I do, I measure the length of news reports. Television news reports, right? I could measure them by doing like an ordinal level, right? Couldn't I? I could say short, medium length, long. I could do that. Or I could do, or I could also do something like, you know, something like, spell it out more explicitly, like less than 1 minute, 1 minute to 2 minutes, 2 minutes to 3 minutes, 3 minutes to 4 minutes, right? Which would be closer to kind of an interval level. Or I could do a ratio level variable. How could I measure it with the ratio at the ratio level? You know what I would do? I would have my little coding sheet. I would ask the question, how long is the report? And I would just leave a little line, a little space for somebody, the coder or me or whoever is doing it, to write in the exact number of minutes and seconds. That would be a ratio level variable. So instead of saying it's short or it's medium or it's long or it's between 2 and 3 minutes, I would say this report is 2 minutes and 43 seconds. So the numbers are completely real now. Okay? So those are the 4 levels of measurement. And this becomes important because you're going to be, by the end of this term, in this few weeks, you're going to be working on your final projects. And you're going to come, if you do a content analysis, you're going to have to come up with a coding sheet. We'll have a whole lecture on content analysis. So I've talked about it a little bit, but it'll solidify for you when I talk about content analysis, probably next week. But so you might have to design a coding sheet, or if your group decides to do a survey, you'll have to design a survey, a questionnaire, and you're going to have to think about how are we going to measure whatever we're trying to measure. Let's say we want to measure people's attitudes about the media, the newspapers in Alabama, for example, right? How are we going to measure their attitudes? Are we going to just ask them? Are we going to measure it using kind of the nominal level? Are we going to use ordinal, interval, ratio? What? These are things that you're going to have to think about. Okay? Scales are important to the research process. And we talk about scales, when we talk about scales, we're usually referring to 2 different things. So you have to be careful with how you read this and how you use this term scale. Sometimes when we say scale, we're referring to a composite measure, and sometimes we're talking about a specific type of measurement item. I'll talk about that in a second. But first, composite measure of a variable. Here, what we mean is with some variables, they're so complicated that we need multiple items to measure them, basically. So for example, I'm continuing with the same example of religiosity, which is a really important concept in our field and in social sciences in general. You wouldn't want to just ask one question and just say, hey, are you religious? Or hey, do you pray? And they're okay, well, yeah, I got my category, I got it, yeah. This person prays, so they're religious. That's really simplistic. Religiosity is complicated, it's complex. So we would want to develop a scale. That's what we mean by scale, a composite measure. In other words, we might have 10 questions, and they all feed into religiosity. They're all about religion. They're all measuring some aspect of religiosity, and that is those 10 questions. Those are our scale. Okay, we basically design a scale. So it's just a composite measure based on several items. That's what we mean by scale in one instance. The other usage of the word scale is as a specific type of measurement item, and that is there are these types of measurement items that we use in our field, like ratings scales or Likert scales. A rating scale, and you've all seen rating scales. When you go to the doctor's office and you're in pain, the doctor might ask you, please tell me how much pain you're in on a scale of 1 to 10. That's a scale. It's a rating scale. A Likert scale, you've all seen these. These are the scales that ask you, the questions that ask you, they're like statements, and they ask you to say how strongly you agree or disagree with something. Strongly agree might be a 5. Then there's agree, which would be 4. A neutral, which would be 3. Disagree, which would be 2. And strongly disagree, which would be 1. So that's a Likert scale. We call that a Likert scale. Those are very common. Use those in surveys all the time. rating scales. Those are specific types of measurement items. There are other kinds of scales too, other kinds of measurement item scales, but I'm only focusing in this class on rating and Likert scales. Let's think about reliability and validity. Reliability refers to consistency over time. When I ask, is your measure reliable? I want to know if it's consistent. In other words, if I ask you on a survey question number 1, what's your gender? And you say male. I might ask you the same question later. You better answer male again. If not, something's wrong with my measurement item. It's not reliable. It's spitting out 2 different responses. Maybe the question, the way I'm asking it, is not clear. And so you said male once and you said female another time. That's probably not a good example because it's pretty straightforward, gender. But sometimes you want to know about the level of loyalty. How loyal is a particular news outlet to the government, for example, or to a particular political party, or to a particular cause, or whatever the case may be. If I ask the question now, am I going to get the same answer in an hour? If I examine the same item, the same unit, if I'm not, then we have a problem with reliability. Let me give you a different example. Let's say you step on a scale. Let's use a physical example. Let's say you step on the scale and you weigh 195 pounds. Then you step off the scale. You step back on. And now you weigh 210 pounds. About a minute later. What's the problem? The problem is with the scale. And the scale is worthless. The scale is not reliable. It's unreliable. And unreliable measures are worthless to us. We have to throw them away because they don't tell us anything. Okay? A really good example of this is and I kind of talked about this briefly when I talked about content analysis. Intercoder reliability. Remember, when we do a content analysis in our field, basically all the researcher does is develop a set of questions. It's called a coding sheet, as I said. Coding sheet. Got like 10 questions, maybe 15, maybe 20, whatever. The researcher's not even going to answer the questions. The researcher's going to gather all the units of analysis, all of the articles, for example, or all of the music videos, or all of the songs, or whatever is being examined, whatever content is being examined. The researcher is going to gather all of these units, all of the content, and give them to 2 different coders. The coders are going to view or read or listen to the content, and they're going to go through and answer every single question on the coding sheet for every single unit of analysis. So, for example, if you have 200, if you're going to examine 200 articles, newspaper articles, they're going to need 200 coding sheets. They're going to sit there and examine, answer the question. They're going to answer all of the questions in a coding sheet for every single article. Okay, so there'll be 1 coding sheet for every article. Okay. Now, as I said, though, what we have to make sure is that these coders agree. Because if they don't agree, then what's the point? Then my coding sheet is worthless. Then I might as well just say, well, anybody who reads these articles, you're liable to find anything. I mean, we might all just disagree about what these articles are saying. But my job as the researcher is to show that my 2 coders, they agree. They answered the questions in exactly the same way. That's very powerful. It shows reliability, intercoder reliability. My coders answered when I asked them the question, is this article more loyal to the government or to the opposition? They both answered the same way on this particular article. And then on the next article, they answered the same way again. So now when I ask this question about loyalty, they are agreeing. And so when you are reading my research study and say, wow, he had 2 different coders reading these articles and they agreed on this particular measure, like loyalty or whatever the measure is, say, wow, that's pretty convincing. Because what that says is that Anybody else who comes along and reads it is going to probably find the same thing. They're going to answer the same way. Because two different people, independently of one another, arrived at the same conclusion. And obviously, when we do these intercoder reliability tests, we don't just do it one time. We do many tests so that we can show a pattern of agreement, of reliability. And if they're disagreeing, if they're all over the place, if I ask, let me give you a simpler example from a content analysis. Let's say I have my question on the size of the article. So I do the old small, medium, and large, right? Is this a small article, a medium article, or a medium length article, or a large article? One of my coders says, so let's say it's article number 1, whatever it is. It's article number, it's unit number 1. The first coder says small. The second coder says large. Next article. The coder number 1 says medium. The second coder says small. We keep going. We do this over and over again, and they don't agree. What would you say about that particular measure? What would you say about my measure of the length of the article, that particular variable? What would you say? If I then, at the end of the day, I published the article and I said 47% of the articles were medium, what would you say? You would say, it's worthless. They didn't even agree. Your two coders, you had no reliability. This measure is not reliable. It's just like you step on the scale, you weigh 100 pounds, and then you step on the scale again, and now you weigh 160 pounds. It's not reliable. Throw the scale in the garbage. Throw that particular measure in the garbage. Okay? So reliability, that's just an example from content analysis, but reliability is important to all kinds of research. And again, reliability refers to consistency over time. Validity is a little bit different. Validity is about, are we measuring what we think we're measuring? Are we measuring what we say we're measuring, what we're supposed to be measuring? Okay? I gave the example last time about internet access versus internet usage. Okay? If you say you're going to be measuring loyalty, you better be measuring loyalty and not something else. And what you have to do is make sure that you control for confounding variables. Because if you're not controlling for confounding variables, then you're not going to be able to say with any confidence that you're measuring what you're setting out to measure. Now, there are two kinds of validity. External validity is very simple, very straightforward. This is where we're interested in whether or not the results of a study can be generalized to the population. So if I did a survey of UNA students, now there are like 7,000 UNA students. If I did a survey of UNA students, let's say I did a survey of 1,000 students. I took a sample. But all of the students were from the departments of mass communication and sociology. What would you say? Would you say that I can generalize to the larger population of UNA students? You'd probably say no. You'd probably say these views are representative of students in mass communication and sociology, but not anywhere else, because you didn't ask students anywhere else in chemistry or biology or theater or whatever. You didn't ask any of the other students. But what if I said to you, I did a survey of UNA students and I took a random sample of 1,000 UNA students. So I have all 7,000 UNA students, their ID numbers in a hat, and I just randomly selected 1,000. Then what would you say? If I do it right, if I do a true random sample, I'm going to get some students from mass communication, some from biology, some from every single major, psychology, every single program on campus. Some will be freshmen, some will be sophomores, some will be juniors, some will be seniors. So now I can say I can generalize to the larger population. In other words, I have a high level of external validity. Internal validity is different. That refers to the extent to which a study really investigates the proposed research question or hypothesis. Again, are we measuring what we think we're measuring? That's where we're going to be concerned with confounding variables. This is just repeat External validity relates to generalization. We use random sampling. I've already talked about that. A random sample, by the way, the formal definition, every single item has an equal chance of being selected. Let me say that again. Every single item has an equal chance of being selected. So you put them all in a hat and you draw them out. I'm going to stop here. Just remember that internal validity, the extent to which a study studies what it says it's studying, and we get internal validity by eliminating confounding variables. So that's my segue into the next and last part of this lesson.